In the branches of mathematical logic known as proof theory and type theory, a pure type system, previously known as a generalized type system, is a form of types lambda calculus that allows an arbitrary number of sorts and dependencies between any of these. The framework can be seen as a generalization of Barendregt's lambda cube, in the sense that all corners of the cube can be represented as instances of a PTS with just two sorts. In fact, Barendregt framed his cube in this setting. Pure type systems may obscure the distinction between types and terms and collapse the type hierarchy, as is the case with the calculus of constructions, but this is not generally the case, e.g., the simply typed lambda calculus allows only terms to depend on types. Pure type systems were independently introduced by Stefano Berardi and Jan Terlouw. Barendregt discussed them at length in his subsequent papers. In his PhD thesis, Berardi defined a cube of constructive logics akin to the lambda cube. A modification of this cube was later called the L-cube by Gouvers, who in his PhD thesis extended the Curry-Howard correspondence to this setting. Based on these ideas, Barther and others defined classical pure-type systems by adding a double negation operator. Similarly, in 1998, T.I.J.N. Borch-Hewish introduced modal pure-type systems. Rohde has discussed the application of pure-type systems to functional programming, and Rohde and Zhering have proposed a programming language based on pure-type systems. The systems from the lambda cube are all known to be strongly normalizing. Pure-type systems in general need not be. For example, system U from Girard's paradox is not. Furthermore, all known examples of pure-type systems that are not strongly normalizing are not even normalizing. They contain expressions that do not have normal forms, just like the n-types lambda calculus. It is a major open problem in the field whether this is always the case, i.e., whether a normalizing PTS always has the strong normalization property. This is known as the Barendregt-Gouvers-Klopp conjecture. Implementations. The following programming languages have pure-type systems: Sage, Yarrow, Heng 2000.